Let's consider the method of substitution for solving systems of linear equations into variables. The first example that we have is y equals to 2x plus 1 and 3x minus 5 equals to 5. This is a system of linear equations in two variables. So we have two equations and two variables. The key idea of using the substitution method is having one of the variables solved in terms of the other variables. So for instance, in this equation, in this system of equations, the first equation is already in nice form. In this equation, the variable y is expressed in terms of the x. So y is equal to 2x plus 1. So what we are going to do is use the expression 2x plus 1 in y in the second equation. So in that case, we say that we substitute 2x plus 1 for y in the second equation. So if you do that, then the second equation turns to be 3x minus parenthesis 2x plus 1 equals to 5. So now we have the equation in one variable, and it's a linear equation, we can solve it. So distribute -1. So we'll multiply, we have -1 here in front of the parentheses. So we distribute it, multiply the -1 by 2x and -1 by 1 here. And we get 3x minus 2x minus 1 equals to 5. Now we combine like terms. So 3x minus 2x turns to be just the x. Minus 1 equals to 5. Add 1 to both sides of the equation. So we have plus 1 here and plus 1 here. And that leads to x equals to 6. So we have the value of one variables. Now we are going to use this value in the first equation here to find the value of y. So we say that we substitute 6 for x in this equation to get the value of y. So we get y equals to 2 times 6 plus 1. And that turns to be 12 plus 1, which is y equals to 13. So the solution of this equation, the solution of this system now turns to be written as an ordered pair. An ordered pair where the first value is the value of x, which is 6, and the second value is the value of y. It's 13. Okay, so I would like to mention one more time that the key idea of using the substitution method is having one of the variables, like in this first equation, one of the variables being solved in terms of the second one. If that is not the case, then you need to modify one of the equations in such a way that you have it written in this form. Let's see how it works in another example. So here's another example. We have 2x plus 3y equals to 6, and 2x minus y equals to -2. So we have two equations, and none of the variables is written in terms of the other variables. So we have to express one of them in terms of the other one. So which one? So that's a key part here also, like which one to choose. Typically, we choose the variable that has kind of nothing in front of them, like 1 or maybe -1. right? But if you don't have that case, for instance, in this case, in this system, we have negative y here. It's easy to solve the second equation for negative y, right? So if we do that, then we're going to get, we add 2x to both sides of the second equation, subtract 2x from both sides of the second equation. So minus 2x here, minus 2x here. Then we're going to get negative y equals to negative 2x minus 2. And then we'll multiply both sides of this equation by negative 1. So let's write that. So times by negative 1. So each term of this equation is supposed to be multiplied by negative 1. So negative 1 times negative y is turned to be y. Then we get negative 1 times negative 2x is 2x. And negative 1 times negative 2 turns to be plus 2. So now we have y solved in terms of the x. What do we do? Next is we get this 2x plus 2 and use it for y in the first equation here. Okay? So we get 2x. The first equation turns to be 2x plus 3 times, and now we write 2x plus 2 equals to 6. Distribute 3, so you get 2x plus, we multiply 3 times 2x here, and 3 times 2 here. Turns to be 6x plus 6 equals to 0. Combine like terms, so 8x plus 6 is equal to 6. Okay, this one's supposed to be 6 here. Is equal to 6. Now we subtract 6 from both sides. And the equation turns to be 8x equals to 0. Now we'll divide both sides of this equation by 8. And canceling out the 8's here gives us x equals to, and 0 divided by 8 is 0. So the value of x is equal to 0. Now we use this value here, this value, x equals to 0. In this equation, y equals to 2x plus 2 to get the value of y. So y is equal to 2 times 0 plus 2, and that leads to y equals to 2. So the answer is 0, 2. So the first value is always the value of x, and the second one is the value of y. All right, so let's pay attention, or let's review a couple things here, making sure that we fully understand. First of all, the equation is supposed to, one of the equations or one of the variables is supposed to be solved in terms of the other one in order to apply the substitution method. Secondly, when you find the value of one variable, you substitute that value into one of the equations in the system to get the value of the second variable. In the second step, like here, when you substitute the value of the variable, you may ask, which equation do we need to substitute? Should it be this equation, or can it be one of these? Okay. And the answer to that question is, it doesn't matter to which equation you substitute. So you get the value of x, you substitute either here, or here, or here, and you will always get the same value of y. Okay? Another question sometimes it appears is, Should we always solve for the simplest variable? Like here we solved for y. Should we always try to find it? What if we do not have that kind of variable, simple variable in our equations or in our system? The answer to that question is you can solve for any variable in either of these equations. So for example, if you want to solve the first equation for x, that is totally fine. If you want to solve this first equation for y, that is totally fine as well. So whatever you solve for, like you solve first equation for x, right? Get the expression and then substitute that expression into the second equation. Okay? So it's totally fine to pick any of the variables and solve for that variable and then substitute the expression into another equation. Okay? So these are the main ideas of using the substitution method, and I hope this video helps. Wishing you good luck.